Hello and welcome back to the lab. Today on the bench we have a DM502A. This is a 3.5 digit multimeter from Tektronix, a very capable unit and can be picked up relatively affordably. I have somewhat standardized on this unit. There's a couple of versions. Some have the temperature probe, some don't. Not too big a deal. This is nice. It is auto ranging. Although for some functions of the bench, it has a weird input impedance. It has a 20 megohm input impedance, which is not 100% common. So not great for high voltage probes, but pretty good for a lot of other stuff. Prior to the channel being a thing, I did a bunch of these units for my personal use. So straight up from where we just were on the bench, we have the meter bank. This is these are two 4-bay frames, each with a DM502A, 3.5 digits. 3.5 digits is very capable for the bench and nothing to scoff at. I have found when I'm doing repairs that I need meters to do two things. I either need them to sanity check something, in which case I do not really care how many decimal places it can get out to, in which case these perform exceptionally well. They also have a very, very good stability over time. All of these calibrated up just okay, except for this one. This one has some bad capacitors in the AC side, so this one's marked DC only. The other way I need a DMM on the bench is on the precision side, and then as many zeros as I can get is what I need. So I either need not a lot or all the zeros, depending on what I'm measuring and my needs are at that given moment. So this works incredibly well for working on multi-rail power supplies, where I can hook up a meter to each power supply and then watch all the supplies at one time. Really helps for troubleshooting. And I picked up these meters relatively inexpensively. So their catalog price was significant back in the day. They were not cheap meters, so they do take very good measurements, and they're relatively quick at it. They're very outclassed by my 6500 and 7510, but still very capable and great to work with. I still use a bunch of them. So if you can pick one up, they are definitely recommended. I have a bunch of them in the lab that I use somewhat regularly. Do not pay a fortune for them, though. I've seen these go for what I would consider a decent price. Under 3 figures would be a decent price, at least in my book. Much over that, and you could be better served by grabbing something new. Definitely don't pay near catalog price for them. They were about $1,200 to $1,500, depending on the catalog you're looking at. So, to repair one of these, one of the huge improvements over this meter's predecessor is in the power supply section. Instead of having a switching supply, we ended up with a linear supply, which really quieted down the power section, makes them real nice. This particular meter, the owner does want a capacitor refresh, so that's what we're going to get started doing. And then I have been requested to run it through an alignment process. I'm not going to show the alignment process in this video. I do have a prior video where I go through the alignment process of one of these in detail. These are relatively easy to align. The tricky part with aligning meters, well, the real tricky part with aligning meters in general is hitting the high ranges. So I have to put in 910 volts to align this at its highest range, because it does have a 1,000 volt input, so they align it at about 910 if I remember the spec right. The other problem is the AC alignment is you have to get very high voltage AC into one of these things, and that's usually where the alignment kind of falls off. So to facilitate that, I have a Fluke calibration standard, and actually 2 Fluke calibration standards, a 5200A with the associated power amplifier. You do need to get the power amplifier to get above 100 volts on the 5200A, and a 434. So I lean on those quite a bit for doing the alignments on these and to get these all topped up. There are more modern units that also need current ranges. This particular unit does not need to align a current range because it has just a shunt. And you pass a current through it, and it just measures the voltage drop on the shunt. These also have a low current range because they are in the milliamps. So I believe 2 amps, 2,000 milliamps is what these go up to in terms of current. So definitely more laboratory style devices as opposed to industrial type devices, but still very capable meters. But so we can get there. So with that, let me warm up the soldering irons and we will get into some capacitor replacements. I thought I didn't have to do much with capacitors. What is... That's a bodge. Okay. We have a bodge cap right here. I do not think this cap is present in some of my other units. It is, but it's a different layout. So it looks like we have a board update. 502A. Oh, this is also a 700,000 serial number, so that would mean this one is made in Havereen in the Netherlands. So this is actually a Netherlands unit. Okay, I really don't understand this. So here's our 2 units. One of my units is on top and customer's units on the bottom. And here's our cap in question. So we have the cap going from this point in the circuit here over to the bottom end of this 0 ohm resistor, possibly a fusible link, possibly just a jumper. But on all of my other units, this capacitor actually terminates here into this point right there. So I'm going to have to get a schematic and see what this is and where this goes, because that may not be in the right spot. Because here's the cap up here, and it goes to here. I've got 8 examples, and they're all wired this way, not this way. So I'm really concerned about that at the moment. These capacitors over here are wet tantalum capacitors encapsulated in glass and extremely high quality. This is also a polystyrene capacitor, very extremely high quality. So none of these need to be replaced. The ones in question are going to be this cap, and these. Flip this around. These 3 in the power supply. This one's gotten hot. I can tell the heat shrink's pulled off a little bit. And then possibly this capacitor right here. This one, this is an electrolytic. That can probably get replaced as well. I'll have to service and clean all these switches, get them ready to go. So, very strange questions on this one. Okay, let's deal with this craziness right here. I am going to wire this to agree with my other units. I really don't know how I'm going to get this capacitor out of there because this is wedged in there pretty good. I got 2 leads going into the same hole. This is a very early unit, serial number wise. There we go. And I heard a sizzle on that, even over the solder sucker, so that was not good. That means there's probably electrolyte coming out of this thing, so it's a good thing we're swapping this one out. This is a 10 mic by 50. I have plenty of 10 microfarad caps in stock, so we are not going to have a trouble replacing that one. All right, solder sucker right here. Also, we're going to put some solder here where that cap goes. Some fresh solder will make removal easier. All right, nice clean pads. Yeah, the seal had gone. I do see the bottom of the cap. It's not going to show up well on the camera. Bottom of the cap is a bit wet, so that one was starting to leak. So definitely a good one to check, and definitely needs to be replaced in this unit. That being the case, this capacitor is the same thing, so we're going to do the same on that one. So I will get 50 volts by 10 mic. Okay, I did see a little bit of electrolyte had started to get into the board, so we are going to clean this up. And I'm going to refresh the solder on this pin, because I do not want this unit's owner having trouble after it's been through a procedure here. So there we go, Q-tip and 99% isopropyl alcohol. And what we're going to do is we're going to touch up the solder on this component, on this jumper. That looks better. And get rid of the flux. There we go. Okay. So what's also interesting is, I don't know if this is an original part or not, because in my example unit, it is a 35 volt 10 mic. This is a 50 volt 10 mic. So the plot thickens a little bit more. I did check for due diligence. The boards are the same revision. So what that essentially means is the PCBs didn't change. So if they're the same PCBs, I don't understand. I really don't understand the weirdness with this particular capacitor. But I do like the way that'll stand off the board. So I need to vastly shorten these leads up. This batch of equipment that I've gotten has been the gift that keeps on giving. It's kept it interesting. So I'm really glad I got the chance to work on these units for the gentleman that owns them. Refresh the solder over here. That moved while that was cooling. That didn't. That's fine. All right. Got to do this one next. That is again a 10 microfarad by 50. On that one, the seal looks okay. We're not leaking. So that one doesn't look too bad. But we're going to swap it out because the other one leaked. I can tell by the sound of the gun it needs a little bit of cleaning. Too big. So clean out the tip and let it pull some vacuum. These desolder guns are very fantastic tools. Any brand of desolder gun is a very fantastic tool. They do require some cleaning and upkeep. Okay, so I had two ways I could put this. I could orient this capacitor in here, and I figured laying down on the negative lead would probably be the better option of the two. So we're going to solder the negative lead in. I'm going to bend the cap over, and then I need to shorten that up significantly. That'll hide out in between those ICs. Very nice. I could have put it this way, but it was a little close to the pins. This way, at least if these ICs have to come out, I don't have to mess with this cap, and it's out of the way. So this was the best orientation I could find to put it in. So there's our two caps on that side fixed. The next one we have to do is that one right there. Now, this one's going to be fairly tricky to do because I need to be really careful of the ceramic hybrid cathodic resistor, and then these are switching relays. So I need to be really careful of those too. Here's the caps get this in frame. Here's the caps we replaced in the power supply. They are already done. So I'm going to start over here. Add a little bit of solder, keeping the iron away from the relays. And a little bit of solder, and I need things to move easily, which they are now moving easily. All right. Fresh solder. The alloy of the solder as it ages, it really doesn't like melting. So putting fresh solder on makes everything melt a bit easier. Let's see here. That is a Sprague. Oh, that is a special cap. Okay. What do I have? That might be why I never replaced them in my units. It is a 10 microfarad, 25 volt NP capacitor. Now the NP actually stands for non-polar. Let's see what I have for bipolar caps. Well, I scoured the wall of capacitors, and I did not find a bipolar capacitor that would fit this position. This is a 10 microfarad. That's actually pretty big for a bipolar. So it's going to need to be another electrolytic cap if I do end up needing to replace it. I'm not sure I will at the moment, but all of my units still have this capacitor in position. The other problem that we have is I looked into a film style capacitor for this position, and what ended up happening there is dimensionally it was too big. I could get the length right, but it was a really wide capacitor, would not fit in this position. So that was out. So we'll see how it calibrates. If it calibrates okay, it won't be bad. If it needs some assistance, we'll give it some assistance. This is the capacitor in the 1 meter that I have. This one right here. This is the one that went bad. There's not enough adjustment range, so it's either this cap is leaky or this cap is toast. And that's why the AC range didn't want to calibrate. I will probably fix my own meter someday. So what we'll do is we'll put some power to this, see if it gives us, at least sanity check it with a power supply, and see if it gives us something that resembles a DMM. Okay, test power supply is in place. We are hooked up to the current limited, variac, and power supply. Everything's turned on. This is we're going to hit it. We got 123 volts coming in. And no smoke, so that's good. And it is showing us a display, which is excellent. Let's grab a pair of meter leads. All right, we want to measure DC, we want to measure auto range, and we want to be on the external input, which we are, and everything is all good to go. So what we want to do on the Rigel supply, we will ask for 10 volts, and we'll current limit this just in case anything goes crazy. 0.5 amps, so 500 milliamps. And here we go. I can't ask for better than that. So, looks like we're pretty good. I'm going to let this burn in for a while. Obviously, we do burn-in testing here. And go from there to spin up the Cal gear, which I will probably do tomorrow, as it's on an hour-and-a-half plus warm-up. Everything is good to go. For those that are curious as to what the unit is doing, 123 volts, drawing about 219 milliamps, and that's 12 watts. Okay, well, we've had today has moved into tomorrow, and the unit has passed a decently long burn-in. I've got the long warm-up gear spinning up. The calibrators are turned on, warming up. The 7510 is turned on and warming up. Frequency counter's on and stabilizing, as well as the 6500. Don't need to let this warm up for an hour and a half for this alignment, but just to give it good measure, we're going to do that anyway. Won't be a problem. So, through the magic of the camera, what will be an hour and a half to me will be about half a second to you guys. But I will be back when all the gear's warmed up and ready to dial this one in. I'll show some highlights from the alignment. I'm not going to do the full alignment on camera. We've already done that in a previous video. So check out the back video catalog and see what's there. Okay, how's our voltage rail looking with the new capacitors? 15.74, should be 15.75. Very close. Let's see if we can't tweak this just a bit. That's just a bump of the control, so I'm also using the wrong tool for this. And we'll call that good. Well, it was doing this before, but we are going to need to adjust the DC 0, which is right here. It's actually not a bad angle for you guys to see what I'm doing. There we go. So it does need to be adjusted a little bit. We do have a nice shorting bar on the front. And everything is good. We're going to need to press into using the fluke next for the voltage calibrators. Actually, that's not holding 0 very well. That should probably move a little bit more. All right, so we're at 1. So we'll go back half a turn, or half the space to get it between +1 and -1 and -0.1 +0.1, so it's right on in the middle of that range. That's a feel. It does not come through the camera very well. Okay, after waiting for a bit of ACAL on the meter to run, I have 2 volts on the calibrator. We're reading 1994. That's a little low. So that does need to be adjusted. Funny thing is, we got some cold weather happening right now, and I am going to have to run the aircon in the lab because the 5205 is putting out so much heat. It was 10 degrees warmer from the last time I ran ACAL on the 7510. So the 5205 is putting out a ton of heat. So I got to run the aircon today. We'll have a fire tonight. It's just a weird day. But here's our potentiometer, and we want this display to be just blinking. That's the wrong tool. Let's use this one. There we go. Sometimes they can be a little fiddly with backlash and a few other things. Okay, we're in a little bit of overload because I don't have anything hooked up, but everything is good to go, and the calibration went all right. This unit was very close to in spec. I was really tweaking least significant digit to bring it in alignment, so nothing really wrong with it. Everything looks good to go. So we get the covers put back on. We'll bring everybody back. Okay, thanks for stopping by the lab and taking a look at the restoration and sort of abridged alignment of this DM502A. This was sent in by a viewer of the channel for me to work on so they could get their own lab up and running, as I have some equipment here that is necessary but scarce out in the field, mainly the 7.5 digit multimeter and a couple of other things. So I do help people tune up equipment from time to time and fill in some gaps where it might be needed. If you'd like to support the channel and help keep videos coming up to YouTube, take a look at the Patreon page. There is currently nothing behind the paywall, but Patreons are about 4 weeks ahead in terms of video releases. So everything hits Patreon first, and then YouTube currently about 4 weeks later. So take a look there, and all the support for the channel goes back into getting equipment for the lab, getting things to put in front of the camera, and also get some videos. We've also had some equipment that has recently become surplus to the lab, so it is available if anybody would like to take a look at that, and that will be posted for sure on Patreon first. At the moment, I don't have a wider footprint for equipment because I don't have a lot that is surplus. But as some things become duplicates from the bench and things like that, we're going to start getting that out to you guys. So I'll make videos on it. You guys will get to see the restorations, but then I'll push the equipment out because the lab is rapidly running out of storage. So, as always, I will see everybody in the comment section between videos. I read all the comments, and let me know how we're doing. And if you have any suggestions or recommendations for future videos, drop me a line either on Patreon or here. I will see everybody in the next video. As always, more is always on the way.